ladies and gentlemen.
So let's talk absolute value. So one common misconception that I've experienced with many of my students is they believe that absolute value is an operator that always makes things positive. And that is only half true. It's true for real numbers, but it's not true for outside of the realm of real numbers. So when you start to take absolute value into account with imaginary numbers and such, using the definition of it takes negative things and makes them positive and keeps positive things positive doesn't really hold up. So a better definition would be absolute value is the distance from zero or the origin, and distance is always a positive value. You can't have a negative distance. So that's definition over. Let's actually apply it. So question 1, what are the possible values of x if 3 times x minus 16 is equal to 5? So we're saying what values of x cause us to have a distance away from the origin of 5? Well, there are two things that would have that. We could have 5 on the inside, and that would be a true statement. Or we could have negative 5 on the inside, and that would be a true statement. So the order of operations when it comes to solving absolute value equations is you want to isolate the absolute values. So if you have a coefficient or you're subtracting or adding on the outside, you want to move all of that over first, then proceed with this idea. So since our absolute value is isolated, we're going to set the inside of the absolute value equal to plus or minus 5. So we set it equal to minus 5 over here, and we'll set it equal to plus 5 over here, or positive 5 and negative 5. Either way of thinking is perfectly fine. And then we solve each of these equations separately. So it could be this is true or this is true. And we're going to solve both of them identically. We're going to add 16, which we're also going to do to the other side of our equation, so we make sure we maintain balance, which gives us 3x is equal to, that would be 11, or 3x is equal to 21, and then we'll divide by 3. So x is equal to 11 thirds, or x is equal to 7. And both of those are true statements. So that is why we have a values for x here. The only way we could get one answer is if our absolute value equaled 0. And do keep in mind that since our absolute value represents a distance from 0, if we had the absolute value of something is equal to a negative number, there are no solutions for that equation. So no solutions exist for this. One solution would exist if it equals 0, and two solutions exist if it equals a positive number. So as long as we're in the real number system. Again, if you're doing standardized tests or you're doing like AP pre-calculus, AP calculus, we're sticking within the realm of the real number system, but do keep in mind that that can get expanded out later. But for our intents and purposes, that's what we got to use. So what is a possible value of x if 3x minus 16 is strictly less than 5? Well, this gets a little more complicated. Well, what kind of numbers would work inside? Well, one, absolute value of 5 is not less than 5. We can't have that. But the absolute value of 4.9 is less than 5. That's okay. And the absolute value of negative 4.9 is less than 5. That's okay. But the absolute value of negative 5.5 or whatever, that would be 5.5. That is not less than 5. That does not work. So we need numbers between negative 5 and 5, non-inclusive, no equals. So this actually turns into the compound inequality of -5 is less than 3x minus 16, which is less than 5. Because the value has to be in between -5 and 5, logically speaking. If the mouth was faced the other way, then we would have to split this into two different inequalities and solve that. Went fuzzy there for a second. All right, let's solve this. So we're going to solve it the same way to solve compound inequalities before. We're going to add 16 to all sides. If you notice, the numbers are the same. We have 11 is less than 3x, which is less than 21. And then we're going to divide by 3, divide by 3, and divide by 3. So 11 thirds is less than x, which is less than 7. So we need something between 11 thirds and 7. 11 thirds is interesting to think about. Largest number I can divide this by without going over would be 9, so that'd be 3 and 2 thirds. So something between 3 and 2 thirds and 7, we could pick 4, 5, 6, or any decimal number fraction in between. I'll pick a 4. All right. Last but not least, we have a word problem, and we're going to have to think hard about this one. So to ride the children's train at an amusement park, you have to be between 36 and 48 inches tall, inclusive. Inclusive meaning you can be 36 inches tall, you can be 48 inches tall. So we're going to put an or equal to whenever we need to put an inequality. We're going to write an absolute value inequality, similar to the one above, that can be used to determine the child is n inches tall, may ride the train. So specifically specifying that it has to be an absolute value inequality means that we can't cheat and say 36 is less than or equal to n, which is less than or equal to 48, which would be the easiest way to write this inequality. We need to write it such that we have this absolute value. So we have two numbers. Let's find what's in the middle. What is in the middle between 48 and 36? 36 to 48, what is in the middle of these two? Well, one way of doing that is you could add them together and divide by 2, or we can find how far apart they are and split that in 2. 36 to 48 is 12, so there's a 6 difference, so 42 would be in the middle. And again, we said that there was a 6 difference. This is plus 6 and then plus 6 to get to each one. So we need them to be 42 is in the middle with a distance of 6. So here we needed this to be in the middle, that what's in the inequality in the absolute value, to be in the middle. And then this represented the distance, this 5, right? So for our case, it's 6, and we need that to be the greatest distance between the middle. So we are going to take our child's age, which is n. We're going to subtract 42 from it. And if the absolute value of that is less than or equal to 6, we're good. Why does that make sense? Well, let's say that we have a kid who is 36 inches tall. We would do 36 minus 42 in absolute value. That would be -6 in an absolute value, which works. Or conversely, if we had a 48-inch tall child, we can set up that absolute value. We'd get a +6 in absolute value, and that also works. And if we test something that is outside of our range, like 50, if we have 50 and we take away 42 from it, we get 8, and the absolute value of 8 is not less than or equal to 6, so it doesn't work. So this is our setup. And sometimes you just got to think about logically how to set up what it's asking. You can memorize formulas all day long, but if it doesn't make sense how you're applying them, then learning formulas really doesn't help. So practice makes perfect with this, and good luck. If you have any questions, let me know. Otherwise, I'll see you in the next video.